This conference will now be recorded.
Yeah, can you hear me?
Hey Shiva. Yes, I can hear you.
Okay. So today we are going to speak about Terraform backends. So Terraform backend is nothing but it is a state file. So when you initialize the current working directory with Terraform and when you download any cloud plugins, what happens? Okay. So along with plugins, okay, and one state file is created. Okay, when state file is created, when you create some infrastructure in one of the cloud platform, a file called tf state file is created. That is called as local backend. That is called as local backend. Okay, but when you are working in multiple multi developer scenario, okay, if you keep this local backend with you, okay, it might be a problem. Okay, because if it is not centralized, if it is local to your system, another developers will not be verifying. Okay, so whatever resources currently available in the cloud, that is a problematic. So if you have local backend, so for that we are going to centralize this state file in a shared location, in a shared location. Okay, so that when it is centralized in a shared location like S3 bucket, Azure storage account, whatever it may be, what happens here? Okay, that file is centralized, and every time when a developer is creating some infrastructure, it is going to verify state file that is stored in central shared location. Okay, so the purpose of centralizing, the purpose of uh, shared backend is multiple developers. When multiple developers are working on a project, so there should not be colliding. There should not be collided resources. Resources must not be redundant. Resources must not be redundant. Once a resource is created, that's enough. Okay, nobody should be allowed to create same resource again. That is why, okay, we have to store this backend in a centralized location, shared location. So
Okay.
till this point, our
Yes.
backend is a completely local backend. Yes.
Yes, Shiva. So when you say backend means where it will create, is it on the servers or somewhere?
No, no. I think I have shown in the very beginning class. Every folder contains a local backend.
Right.
Even our local machine also I will show. So in the last class I have created one backend, right? What is the what is the folder we created in last class? No, not last class, before last class. Terraform Azure, that is 2nd December. What is the 18th December, right? Now let us open this code dot. Now, are you seeing here this terraform.state file here?
Yes.
Yeah, this is the local backend.
Okay.
Okay, since we don't have any infrastructure in my Azure cloud, okay,
Mhm.
all of information from TF state has been moved to this backup file. In the very beginning class, I told, okay, when you
Okay.
create a resource, automatically this state file is created. This state file is local to your system. This is
Right.
called as local backend.
Mhm.
And it is showing that previously you have one network interface, one virtual machine, one public IP address, one network security group. These many things you have, okay, previously.
Okay.
Recently, we don't have any infrastructure. So my state file is completely empty. Okay, we have to store this state file in a shared location. So what are the remote backends actually? Remote backend is nothing but okay, it is a backend file which can be accessed by multiple developers that are working for a project.
Right.
Now, and what are the shared locations actually? How to create a remote backend? Terraform remote backend. Only remote backend. I don't backend types. These are all backend types. Where this is given. Just a minute. I will back. Just give me 1 minute.
Mhm.
Okay. So here these are the backend types. Remote backend types. Here we have buckets. Backend types like S3 bucket, storage account backend. Why it is not showing backend types? Backends. Remote backends. These people are not given. Okay, these are all backends. Remote backends. It can be S3 backend, Azure backend, okay, GCS backend. You can store backend state file information in any one of the clouds or in some area called shared storage. Shared storage. And how we can create remote backend. Now let us create one remote backend in Azure storage account. And to create a remote backend in Azure cloud, we must have to create one storage account first. Okay, storage account resource group, and what should be your backend file name? Storage account means it is one kind of consolidated account for all types of storages. Like storage account is a combination. Like it will be having blob storage, file share, and table storage, queue storage. Everything will be integrated in the form of storage account. Now let us go to this Azure portal. Let us create one storage account first. Now let us create a storage account here. To create storage account here, we are seeing an option called storage accounts here on the left side blade. And click on storage accounts. Okay, create. And it is asking for a resource group name. Presently, I want to create one resource new group name, that is MyRG. And storage account name, account or DS account. 20th December. It must be unique. I'm going to copy this storage account name here. This storage account name. And for Terraform backend, refer here. What is a Terraform backend actually? Terraform backend. Now let us give the link of this application, link of this page. And my resource group name is what? MyRG. MyRG is the resource group name. Group name. And let us create a storage account first. And it is asking where you want to create it in South India. Okay, performance can be either standard or premium. Okay, so here we have these many types here: LRS, GRS. Okay, what exactly LRS, GRS means, I will explain. LRS means local redundant storage. Second one, when it is geo redundant storage, it is GRS. People have given only two. And here redundancy means Azure storage redundant type, replication types. Data redundancy. Yeah, these are the redundancies that has given. One is locally redundant storage. So when you say locally redundant storage, what happens here? Within data center, within a single data center, your data will be replicated for 3 copies, 3 times. Copy 1, copy 2, copy 3. So if this data center is completely collapsed, there is no chance of recovering the data. So this is the least storage option here. Okay. So it is going to secure data against to data center. Okay, if one data center is completely collapsed. Okay, so this will not be recalled. But here within the data center, your data will be maintained across 3 racks. In data center we have racks. Okay, so it is going to protect your data against rack failure. So when data center failure occurs, okay, so your data cannot be retrieved. So to overcome this problem, we have one more type here: zone redundant storage. Zone redundant storage. So in zone redundant storage, what happens here? Your data will be copied across 3 availability zones. So one data center or one availability zone is far away from another data center. Okay, at least in between every data center we have thousands and 1500 miles of distance. So if one data center completely collapsed, okay, another data center will be functioning. So it is going to secure data across data center failure. Here this is going to secure your data across rack failure. Within single data center, your data will be replicated across 3 racks. Okay, if one rack is failed, so you can recover the data from another rack. And another, here this is ZRS. Okay, availability zone 1, 2, 3. And if one of the data center got failure, okay, so you can recover the data from another data center, because so one data center will not be impacted, so will not give any impact on other data center. And another, so suppose you may ask, so completely suppose the zone is down, sorry, completely region is down, so for that AWS Azure has given another option, that is, this is redundancy in a secondary region. Okay, this is primary region, this is secondary region, complete region is different here, but this is going to follow LRS again within the data center of primary region. Okay, your data will be stored. So you may ask, so if this primary region goes, what happens? So we can recollect the data from secondary region. And if you want to replicate the data across zones and regions, here this is other option, geo zone redundant storage. So this is the primary region and this is secondary region. In the primary region, your data will be stored across 3 racks. Not 3 racks, 3 availability zones, sorry. 3 availability zones. But in secondary zone, it is LRS. Your data will be replicated across 3 racks. Okay, this is geo zone redundant storage. This is very important with respect to Azure cloud perspective. I'm going to give link for more information about redundancy. Refer here. Now, while creating storage account, we have to specify either your data has to be replicated. Okay, GRS. So suppose I select another region, Central USA. Maybe the redundant options are more. Central US. Here we have these many options here. In South India, there are no more than 2 options. Here in all USA regions will be having 4 options: LRS, GRS, ZRS, GZRS. I am selecting LRS only. Go to next page. This is all not required. Directly you can create your storage account. Now here, Terraform backend Azure. This is how you can create backend. Storage account name and container name, key name. Key file is nothing but it is your Terraform state file. Now, I have created one storage account, and we have to create one container also, because container is required here. Container name is required. So how to create container? So to create container, here there is an option called containers. Click on containers. and create container. This is my container. We can't create. Here container name is my container. Okay. Now, and we have all the necessary details like resource group name we have, storage account name we have, container name is also there. Key file is tf_state.terraform.state file. Now this information you have to write in provider.tf file. Here we have a file called provider or my, I think, where is that? Provider.
And yeah.
Here we have to fill up these details. So here storage account name is, this is my storage account, DS account, storage account name. Resource group name is my RG, and container name is my container, I think. My container. And this file is terraform.state file. Now we have to reinitialize this. And before that, login into Azure Cloud, AJ login. Okay, select the account. Now everything is done. From here, all you need to do is just you need to execute one simple command again. And before that, let me check whether everything is commented. First, we have to comment everything. VNet commented, RG commented, Mikey commented, BM, VNet, everything is commented. Now let us execute this command once again. Terraform init. Now you seeing Terraform has been successfully configured. And here this file is empty. And let us go and verify in Azure storage account, my container. Are you seeing Terraform state file is created here?
Yes.
And you create some resource. Okay, see what happens here. I will create one resource group. And let us go to rg.tf and let us remove comments. And Terraform validates. Done. Now Terraform, apply, auto approve. Are you seeing acquiring state lock here? When one person is utilizing this directory, it is going to
Yeah.
acquire lock. The state file is
Yes.
locked here. Okay. At the same time, when other developer is working, okay, the developer will not be allowed to create a resource group. Okay, unless and until this person is completed his work. Okay, other person will not be allowed to use same account.
Okay.
Now let us see what happens here. What is this? Exists. Okay. It is telling that it is already exists. MyRG is existed. Let us take MyRG one. Okay, one resource is added. Let us go and verify whether here what is there in this file, terraform.state file. Are you seeing a state file is maintaining all these things here in Azure cloud?
Yes. Yeah. Okay.
And when it comes to this local state file, what happened here? This is completely empty. Are you seeing here?
Yes. Empty. Yeah. I don't see anything. Yeah.
And are you seeing everything in the Azure cloud here? And if I
Yes.
say one more, if I say another developer, suppose another developer is suppose I will create one more folder here. Let us create one more folder, new folder, Terraform, Azure, backend, another developer. And here I will open this. I will go to git bash. I will exactly take this code. So for the second developer also, I am going to use the same backend. Let us take this. I am copying the same code in second developer working folder. Second developer also has to initialize backend. Here provider.tf. Here this is Terraform Azure backend second developer. Now execute Terraform init. Okay, it is also saying that backend has been initialized successfully. Now let us copy this file here from the first developer first developer work area, working folder. I am copying this to second developer. See what happens here. Now let us create same rg.tf. From second developer also. Okay, if you execute Terraform, show duplicated backend configuration. Okay, previously configured. Okay, it is correct. And when you execute Terraform, apply, auto approve. Backend RM. Okay, so it is telling that already backend is created. Okay, so we are not able to create again one more backend because from second developer also we have created same thing. Wait, this is coming provider RSM already given provider rg.tf. Okay, I think in rg.tf I have copied same thing. That is why it is giving this message. Let us remove it and let us copy this from first developer to second developer machine. Control C. Let us copy this. Now if you execute this one, Terraform second developer, Terraform show. It is going to refer. Are you seeing here? My RG1 is already there. And if I execute apply command, it does not create anything here. Auto approve. Acquiring state log. This may take a few moments. Okay. So it is going to show that a message like your configuration matches infrastructure. So you need not to create anything. Are you seeing here? Your infrastructure matches configuration. No changes.
Okay.
Because for both developers, backend is common. One backend. Okay, what is the backend here? Backend. So my first developer working Terraform folder and second developer's working folder also going to refer same backend.
Mhm.
Is it correct or not?
Yes.
That is why when you are trying this resource creation from second developer, okay, it is not doing. Are you seeing here no changes? Your infrastructure matches the configuration. It is referring. Okay, it is referring in remote backend. Okay, so since already this information, this configuration is there in Azure state file, okay, it does not create anything.
Okay.
So like this, so you can centralize, okay, our backend. So the backend location can be anything, Azure storage account or S3 bucket. In S3 also you can store a state file. Okay, So for storing S3 file in S3 bucket, AWS S3 bucket, there are documents. Terraform backend S3 bucket. S3 example. All you need to do is just you have to create one bucket. That bucket name you have to specify. This one. In the place of Azure RM, you have to write back bucket S3, bucket name, key value. Okay, key value is terraform.state and region equal to east to US1.
Okay, got it.
This is AWS for AWS S3 backend. Refer here. This is sorry. This is S3 backend. All you need to do is just you have to create one bucket and yeah, the bucket name you have to specify. Okay, in your configuration file, state file, not state file, configuration file. While in provider.tf file. Okay.
Okay.
So till this point is everything clear?
Yeah, Shiva. Yeah.
Okay. Now in the previous class we have created multiple resources of same type. And I think we have used count equal to something, count equal to length of subnets dot length of variable dot subnet dot cadr. We have given like that. Count equal to something means that particular block will be executed for many times here. So if you want to create the same type of resources, okay, you can use count. And count is having some drawbacks because so when list is created and when the list is changed, it is going to recreate, okay, all the infrastructure. That is unnecessary resource creation involvement is going to be occurred. So to overcome this problem, okay, Terraform offers so one more meta argument called for each. Okay, for each is also same as count, but since count is having some limitations, count will be working on only list. Okay, so if at all if you want to work on data structures like maps and objects, okay, we have to use for each. The limitation of count meta argument is you cannot work with data structures like maps, objects, etc. And when the list items are changed, okay, count recreates the infrastructure. Okay, let us see how it will be. Suppose here we have something like variable uh, instances, and here I am going to write type equal to list of string, and I have written resource block. This is AWS EC2 underscore resource 3, and by default I have given some strings here. Default equal to instance 1 and instance 2. And in the resource block, what we are going to say, so here AWS S3 underscore, sorry, AWS underscore EC2, and we are going to create resources, and we are going to say something like variable dot instances. Here inside this, we are going to use something like count block. Okay, now count block is going to create two instances, because in instances variable we have two strings, instance 1 and instance 2. And suppose instance 3 is also there. Instance 3 is also there. And in resource block, we are going to use something like variable dot instances. And it is going to create three instances, because in instances we have three strings, so that it is going to create three resources. So when I say count equal to variable dot, we are going to write like this, length of variable dot instances. Now this block will be created for three times. This block will be created for three times. Suppose I changed, I have modified, or I deleted one of the string from this list. What happens here? Terraform is going to destroy all the instances, and it is going to recreate instance 1 and instance 2. Okay, so
Okay.
Terraform does not retain the indexes, does not keep instances, does not keep index numbers like 0, 1, 2, 3. It does not remember anything. That is why whenever the list is modified, okay, it is going to recreate the instances. That is
Okay.
a big drawback of count. Yes.
Yeah. Got it, Shiva. Yeah. Understand.
So to overcome this problem, okay, Terraform is going to offer one excellent looping concept called for each.
For it. Okay.
And now for using for each, okay, we can create multiple resources, and for each will also be working on different data structures like list, set, list of objects. But for each is going to take only set kind of data structures. So it does not take list object. So we have to convert a list to set. Okay. So I have some examples here. First, let us do this activity. This is second developer, right? From first developer, I am going to destroy this. Terraform, destroy, auto. Now let us create three resource groups or three storage accounts in single shot by using for each. So how for each is going to work? Let us here. Here I am defining few variables here, and first I will take one simple example. Here I am defining a variable here. Variable resource group names and a default equal to here this is a list RG1, RG2, RG3. Three resource groups I am creating. And to create resource group, already we know that we have used a block, resource block called Azure RM underscore resource group examples. And here this block will be repeated for 3 times here, because in resource group names we have 3 values here, and for each is going to take only set values. So but this is a list, so we have to convert this list into set. So to convert that list into set, okay, we have a function called toSet variable dot resource group names. And here this block, this Azure block, this resource group block will be repeated for 3 times here. And since we have 3 values here, this becomes keys here: RG1, RG2, RG3. And location where you want to create this resource group, 3 resource groups here in East US. East dot key means first time each dot key becomes RG1. Second time each dot key becomes RG2. Third time each dot key becomes RG3. Now let us run this from our example, from our working folder. So I am going to rename it as for each rg.tf. Let us validate this. Terraform validate. Now it is acquiring state lock. Now it has to create 3 resource groups. Okay, 3 resource groups were created. Now let us go and verify whether resource groups are created or not in the account. And resource groups, refresh it. Are you seeing RG1, RG2, RG3 are created here?
Yes.
Now this is for each which is written on a list. So if you want to work on a map of objects, okay, so here this can be written like this here. Now this is going to create 3 storage accounts. Okay, so you have to create 3 storage accounts. First SEA1, SEA2, only 2 storage accounts. So here variable name equal to storage accounts, type equal to map of object. Okay, map is going to have key and value pair. Okay, whatever you are writing on the LHS side of equal to symbol, these are keys: name, location, kind, replace, replication type. These are keys,
Yes. Okay.
and these are values here. And in this storage accounts, we are going to use these fields here: name, location, kind, replication type, and tier. And first storage account name I am giving like storage account default equal to storage account 1. Name of the storage account will be this one, West US 3, and this East US Now this is variable declaration. Once my variable is declared, so if you want to use this is a small resource block. And if you want to refer all these values, okay, there is a loop concept here. Each dot value dot name. So each dot value dot name means for first time the name will be this one. And next location, resource group name. Okay, rg dot name. So what is rg dot name here?
Yes.
rg1. What is resource group name? Resource group name is not given here. rg dot name. rg dot name. Okay. rg dot name. Okay, so let us define one more variable. Variable name is rg type equal to screen default equal to I new rg is a default value. Resource group name equal to rg dot name. Rg dot name means let's create a resource group.
Why?
Rg dot name location name equal to value dot name. Each dot value and okay, let us give a fixed value and location. So location for first storage account will be West US3. This West US3 will be substituted here. Location. Account kind equal to LRS for first storage account. Second storage account, the storage account type is
GR.
replication type is DRS. Okay, here he has given resource group name. Okay, now let us write this variable part first. Is it tested everything? Right. Let us create one more file, storage account .pf. And let us create one resource group also. Okay, otherwise write this in variables.tf file. In vars.tf, we are going to copy this. Let us create one resource group also, as mentioned in the web link. You have this one. Here it has given the subnets. So this is variables. Now in storage account .tf, what I will do, I will take the code, write it over here. rg.name, where the rg.name is defined here. Okay, let us do this. But you can create three resource groups, in the three storage accounts in single resource group. That is also okay. And in the place of name, I will write SG, but it is going to be repeated. Okay, let us write these two things. In vars file, I am going to define variables also. Copy. Okay, I am going to cut it from here. sca.tf. Now let us validate this. Terraform validate undeclared resource rg.name. Okay, so let us do one thing. These are, let us do some activity here. Resource group name I am going directly, I am giving RG1. Let us do this activity. Okay, now it is valid. Now let us apply. First it is creating SCA2 and SCA1, SCA2 and SCA2. Storage account 1 and storage account 2. And within RG1, resource group 1 only, it will create 2 storage accounts.
Okay.
What happened here?
Releasing state lock.
And okay, already taken. Okay, let us give some other values. December, SCA1. This is 20 December, SCA2. Here, unable to locate. Okay, let us copy once again. SCA.tf. What is this? Resource group names. Submit it. Okay. Now everything is destroyed. Now let us give new storage names. 20 December SEA1. Sys 20 December SEA2. Open your storage account. RG1 could not be found. Okay. Okay. Let us say my RG. This is my RG. Okay. Two storage accounts are created. So where to see? These are storage accounts. Are you seeing 20th December SEA1 and 20th December SEA2? Here.
Yes, yes, yeah.
Okay, this is how you can use for each loop. Using for each loop, you can do wonders. You can do anything. Okay, it will work with any kind of data structure. That is advantage of for each. Okay, so I will forward these notes and Terraform script in Google Drive and go and
Okay,
practice this. If you have any questions in the next class, we can discuss. Okay,
sure, sure. Yeah,
thank you.
thank you.